Patterns in the periodic table. Distinguishing electron, the last and highest energy electron found in an element. Representative elements are found in groups 1, 2, and 13 through 18. Elements have similar properties in vertical columns. The distinguishing electrons in these groups is in the S or the P sublevel. These groups. Transition elements found in groups 3 through 12, the distinguishing electron is in the D sublevel. The intertransition elements, the lanthanide and actinide series, the distinguishing electron is in the F. These are the transition elements right here. And this, the lanthanide series and the actinide series. Properties of metals. Transmit heat well and electricity well. Ductile, which means metals can be made into a wire. Malleable, metals can be hammered into thin sheets. They have a shiny luster. And the ones listed in the green are metals. Properties of nonmetals. Brittle, powdery solids. Sometimes they're gases. They're on the right side of the periodic table. The ones in the yellow are the nonmetals. Notice you have many more metals than nonmetals. Properties of metalloids. They're intermediate between metals and nonmetals. They're semiconductors of electricity, silicon chip, for example. And if you look, the metalloids are the ones in the red triangles. There are very few metalloids. As the atomic mass increases in a group, vertical column, the element is more likely to be a solid. For example, in the halogen family, fluorine and chlorine are gases, bromine is a liquid, and iodine and astatine are solid at standard temperature and pressure. Metallic properties in general increase as you go down in a group and to the left of the periodic table. The most active metal on the periodic table is francium, right here. Nonmetallic properties, excluding the noble gas family, which is the final column on the periodic table, they increase up in a group and to the right. The most active nonmetal on the table is fluorine. It's right here. Francium is the most active metal down and to the left. The most active nonmetal is fluorine up and to the right. This is your noble gas family. They're basically inert, non-reactive. Size. In general, it increases from top to bottom because you're adding an additional shell, and in general it decreases slightly from left to right in a period in a horizontal row because more protons in the nucleus pull the electrons in a little bit closer. Chemical activity in an element is dependent on the arrangement of the electrons in the outer shell. Ionization energy is the amount of energy it takes to remove an electron from an atom during a chemical reaction. Generally, it takes less energy from top to bottom in a group because the elements at the bottom of the group have their electrons further from the nucleus, and those electrons are held less tightly. There's a slight increase going from left to right in a period in the amount of energy it takes to remove the first electron, the first ionization energy from an atom. This is because there are additional protons in the nucleus which hold the electrons slightly more tightly. Chemical activity in an element is dependent on how those electrons are arranged around the nucleus. The valence electron, those are the electrons in the outermost shell.